All right, so let me share my screen. And Madison, can you tell me, do you see an exercise in front of you? Okay, so, and you guys interrupt me if needed. I'd be totally fine. I'm just gonna kind of walk through these, and we don't necessarily need to use the textbook. We can certainly refer back to it, but I'm going to just kind of explain to you how this works. So number 16, what they're trying to do here is we're calculating, actually for number 16, I think it would be a good idea that we read it. So this is on page, number 16, we're just looking at internal rate of return. Okay, so that is our fourth and final method. This one also factors in the time value of money. Okay, so what we're doing here is the first thing before you can calculate internal rate of return is you got to calculate in letter A there the factor. So make sure you make that note. That 3.785 is nothing more than the factor. And let's look at this formula, which is amount to be invested divided by the annual net cash flows. And that may or may not ring a bell with you, but that actually is the same as cash payback. Amount, so the investment on the top, and then your annual cash flows on the bottom. And that would say, so that's 113,550 divided by 30,000, that's 3.785. That's the factor, but that's also 3.785 years, and it pays itself back. So it's not like you're learning something new, but when you get to the internal rate of return, you actually got to first calculate this factor or cash payback. And then what you do is you got to go into the book, into the exhibits, either at the back of the book, in the appendix, or in the chapter, exhibit 5. It's the annuity table. And what you do is you scroll down on the left-hand side to the number of years, and this one was 6 years or 6 periods, so you go down to 6, and then you scroll across to the right until you find that factor. And I would say, please do this one with me so you see how this works before you get to the test. So you go to exhibit 5, you go scroll down to period 6, row 6, scroll to the right until you find that factor. And then when you do get that factor, point up or look up, and it aligns to 15%. So this investment has an actual earnings of 15%. Does that make sense? Anybody have questions on that? We'll do more of these, but that's the internal rate of return. Please stop me if you got questions. So then if we go to 19, all they're asking for you to do here is 2 things: net present value and internal rate of return. Both of those factor in the time value of money. Well, I'm going to scroll back to what we did last time. So if you look back, like in this exercise here, this net present value calculation, this is the same no matter how we do it. If it's a different cash flows every year, we have to list them all out and take it times all the factors. If it's the same, like in number 19, you see, it's an annuity. It's $35,000 every year for all 8 periods. Well, then you can use that annuity table. Now you could go to that lump sum or the present value of a buck table, but you'd have to list it out 8 times for 8 years. Or you go to the annuity table and you take it times the factor, and this is just like in the one earlier, amount to be invested. Well, in this case, it's a negative net present value. That's the first time that we've had that. always has been a positive. Well, that would mean we would most likely reject this proposal. Now, the problem is it's a negative 12, but we don't know how low below 12% in this problem are we? How far below? Is it 11.99? Is it 8? We don't know. So net present value just tells you either you are at 12%, which this would be 0. A plus would mean it's more than 12, and a negative means we're below 12. So then if you take what you know and you go to the internal rate of return calculations, what you would do is you'd say, okay, amount to be invested divided by the annual cash flows. So the amount to be invested is right here, that 186. The annual cash flows was 35. So that is 5.335 years and it would pay itself back, or that's the factor. Well, now if we go again back to Exhibit 5, scroll down to 8 periods, run your finger across to the right until you find that factor of 5.335 and look up and it aligns to 10%. So we didn't make 12%, but we now know it's exactly 10%. Questions on number 19? All right. Oh, was there a question there? Nope. 21. 21 is the same thing again. In number 21, they just want you to calculate net present value. And notice we do it the same way again. Get all those present values. Now, let's go back up here. This one, we only did it one time, right? Because it was every 8 periods was $35,000. But we get to the amount invested and the net present value. Now, if we look at this one, it's because it's different cash flows for every year, we have to put in all the present value factors, but we still get to this total amount to be invested and then the net present value. So number 21, what they're doing here is they're looking at 2 different alternatives, the processing mill or the electric shovel. There's one thing that I think that needs to be clarified so that you see it. You notice there's 2 year 4s. Well, the deal is here, and when you read it, this thing had a life of 4 years. And after the 4th year, the residual value is 280. So they're going to get that cash back. So to compare all the cash flows from the 4 years of the electric shovel to the 4 years of the processing mill, we got to keep them, apples to apples. We have to include that residual value here. And because it's a different cash flows for every year for both alternatives, we have to list them all out, the present value of $1. So we list those all out. In this case, both of them have an investment of $750. This one is, roughly $20,000 greater than this alternative. But we can certainly say this, it's greater than 15% for both of them, right? We don't know exactly how much because we're not calculating the internal rate of return, but we do know it is better than 15%. Any questions on number 21? Okay. Let's look at problem 1A. So problem 1A asks you to calculate what? 2 things, average rate of return and the net present value. Well, for your notes, you make sure you write this down, average annual rate of return, which means when we're looking at rates of return, and that would indicate income. So right up here is this is the total income for the project. It was for 5 years, so we divided by 5. Annually, the average is $11,250. The cost of the project for this is $75,000. At the end of its life, it was 0. So make sure you note here it's a plus. 75 plus 0 divided by 2, so we get an average, beginning and ending average, is 37.5. Since this one has 5 different numbers involved, we have to divide it by 5. This, we only divide it by 2 because it's the beginning and the ending. It has an average rate of return of 30%. No time value of money, right? We're just calculating the hard numbers. Letter B, they want you to do the net present value. And if you notice, it's the same setup like we've done in the past. Just do it very consistently. Because it's different cash flows for the front end loader, we have to list them all out. We would not have needed to do that for the greenhouse, right? Because it's the same. However, what they're trying to do here is just line everything up. Now, you could have done this problem twice, once for the front end loader, once for the greenhouse. That's totally fine. Or just you're going to write these all down anyway. Just list them all out. So 0.893 times 40 is 35. 0.797 times 35 is 27, or 0.712 times 26,250 is this 18,690. The summation of all of those net present values is 99,900 and 94,600. You take away the investment of 75. It has a net positive of about a $5,000 difference between the two alternatives, almost 25 and almost 20. Both of them, we can say, exceeds the 12% hurdle. Both of them are above the 12%. Just want to point something out so you see how these present value factors work. Notice here, 0.893. So what we're saying is, if we're going to get, let's just use this one, 26,250 in 1 year. It's 1 year. What is that worth today? Well, that's worth 23,000. So if I put 23,000 in the bank today, don't touch it, it'll grow 12%. At the end of 1 year, it'll be 26,250. On the flip side, if I'm going to get 26,250 in 5 years, what is that worth today? 14,800. Does that make sense? Because if I put $14,884 in the bank today and not touch it, for 60 months, it will grow to 26,250. So that should make sense to you, that something that we're going to get in a year is worth a whole lot closer to 26,250 versus something that we're going to get at the end of 60 months versus at the end of 12 months. Does that make sense to you guys? Be sure to interrupt me if you got questions. All right, then problem 2A. 2A, they actually ask you to do a cash payback and a net present value. Well, cash payback is really kind of unrealistic, but this plant expansion pays itself back $450 each year for a $900,000 investment. Takes 2 years to pay itself back. The retail store, it also does a nice round, 500 in year 1, 400 in year 2. So in 2 years, it pays itself back. So both scenarios pays itself back in 2 years. Okay. Cash flows. So what we are looking at here is cash payback. Investment divided by cash flows. All right. Then if we look at net present value again, nothing new here, right? Notice here, all different cash flows for either the plant expansion or the retail store. You have to use all of the lump sum calculations, all of the present values of a buck. Their hurdle is 15%. 0.870 times 450 is 391. 0.870 times 500 is 435. Calculate that all the way down. Again, both scenarios had a cost of 900,000. Is a net present value. Both of them very close, 305, 310. Based on this, we would recommend the retail store. Both of them are above 15%, right? Because it's much positive. Even if this was 0, it would mean that we met our hurdle. It meant it was 15%. Okay. Questions on 2A? On 4A, what they want you to do here is calculate both net present value and internal rate of return. Well, we'll take just a couple of minutes here and look at the net present value. Again, it's two alternatives. Nice thing here is annual net cash flow, so we don't have to calculate each year individually. It's the same, 280,000 each year times the factor. We can go to the annuity table now, right? Exhibit 5, 6% for 4 years. You take it times the factor, and that gives you the annual net, the summation of the present value of cash flows, 970,200. Take away the amount to be invested. Here's a positive 82,000. Same calculations for biofuel equipment. However, it's a much larger net present value. I just want to point out one thing. When you're looking at the present value factors for individual years, this table that you look at, which you go to that exhibit or that appendix, if it's the present value of $1, there is nothing on that appendix or in that exhibit that is greater than 1. Every one of these factors on that page is less than 1. If you go to the annuity table, all of the factors there are greater than 1. And it has to be because you're only taking the one annual cash flow times the number of periods that's the same number. So in this case, it is 4 years. You have 280,000 each year for 4 years. We got to look at a factor that basically includes all 4 years of individual present value factors. Okay? So that's the present value. Nothing new there. Same thing that we did before. Now there's something that I want you to make sure you really highlight, make a note of it, because this is the first and the only time that we'll ever talk about present value index. We don't do anything with that. You will do more of that when you take managerial finance, but for this class, you'll never talk about this again. So the present value index as compared to number 2, present value factor, they're not the same. This one you don't need to worry about for me, but for Cengage, you're going to have to do it, which is just the present value of the net cash flows divided by the amount to be invested. So the present value of those cash flows, 1,039,000 divided by 911,100. That is the present value index. Just leave it at that. But part 2, it says calculate the factor. All right, well, cash payback, amount to be invested, 887,600 or 911. I'll show you again. 887,600 or 911,100 divided by the annual cash flows. And in this problem, it was 280 and 300. So the wind turbines will pay itself back in 3.17 years. The biofuel equipment will pay itself back in 3.037 years, or these are the factors. So we will now go back to the annuity table in your book, Exhibit 5. Go to the left-hand side for 4 years, looking at 4 periods, walking across to the right. You find the factor 3.17, look up, it's 10%. Again, go 4 years, go across, 3.037, look up, it's 12%. And if you think about it, that makes sense. The biofuel equipment pays itself back ever so slightly quicker than the wind turbines, right? It's 3.037 years versus 3.17 years. Well, that means you're getting your money back faster, which means you're earning a higher interest rate. So the wind turbines should be slightly less than the biofuel equipment. So in this problem, I would tell you what you really need to remember is right here, know how to do the net present values, of course, and right here, the present value factor, and then getting to the internal rate of return. This part B here, you don't need to worry about that. You'll need to do something like that on Cengage, so make sure you understand that, but you will not be tested over on the present value index. And the only reason why it's on Cengage is because it's in this problem. Okay, can anybody let me know if you got any questions? I will stop sharing here. I don't know if I'm back or not. Any questions from you guys? Does that make sense? It's not so bad. So let me think, what else do I have for you today? Your guys' final is on Wednesday, right? Wednesday at 10:30. And I sent you a review sheet already. That is all I have for today. I'm gonna, I'll send out another invite on Thursday, and that's just to go over questions with anybody. So you don't have to come, but if you do, I'll go over the review sheet. I'll answer any questions that you might have, and that's about it. Anything else for you guys? We will not meet on Tuesday. Our last time, technically we're supposed to on Tuesday, but I'm going to give that to you guys just to get ready for your Wednesday final or whatever you have. Yeah, well, you got mine on Wednesday, but we're done. Even Thursday is going to be short. Today, it's only about 22 minutes so far. So, yeah. Yep. Meaning you'll have your 3 take-homes on Cengage, and then you'll take the, if you will, in-class exam or whatever on the LMS. And those are only multiple choice. Yep. And then later today, I'll send out the assignment for the paper that you remember in the syllabi we talked about that. Not funny right now, is it? All right. Anything else for me? Anybody? Hey, I appreciate you guys logging in. You're the only 3 human beings that I get to see today outside my. Aren't you sick of this being cooped up? Jeez. But I think it's going to get better, and then this summer it'll get way better, and we'll be back in the fall. So, all right, you guys have a great day. Good to see you.